Okay, this is the video lesson for Algebra 1B 6.4 Applications of Linear Systems. So what we're going to do is, this is just going to be a bunch of word problems, and we're going to be using linear systems to solve them. What we just did in 6.1, 6.2, and 6.3. Right, 6.1 we learned how to solve systems with graphene, and basically for these we have to figure out which method to use. So this is going to tell us when to use it, right? If you want a visual display of the equations, or you want an estimate of the solution, you can use graphene. Substitution you use when one equation is already solved for one of the variables, right? That way you just substitute it right into the other one and solve it. So that makes it easy. Elimination is when the coefficients of the one variable are the same or opposites, or when it's not convenient to use the other two. So elimination is probably the most common just because there's more times to use it. And just as a definition for what for this next problem, a break-even point for business is going to be the point at which the income equals the expenses. Right. So if you have a business, you're selling things, you have to buy that stuff, and then so you're spending. So those are your expenses, and then to sell them, you get your income. Right. The break-even point is when they're both the same. Right. So you wouldn't make any profits off that. That's a break-even point. Okay. So this first problem asks. Or says that a fashion designer is making and selling hats. The material for each hat costs $5.50. The hats sell for $12.50 each. The designer spends $1,400 on advertising. How many hats must the designer sell to break even? Okay, so break even here, that means right where income is equal to expenses. So let's see what we're talking about. We have expenses, which are going to be the material, right? This is an expense. And then advertising is also an expense. Okay, so if, let's see, what we're trying to find, how many hats? So let's say X is number of hats. Okay, so his expenses are going to be 1,400 plus 550 times the number of hats. And then that's going to equal, we want to know when the break even, that's going to equal income. This is my income, $12.50 per hat. So my income is going to be $12.50 per hat, which is X. So $12.50 times X. And so the break even point is when these are equal. So this is a nice system. It's just one equation, really. So let's just solve this. We only had one variable anyway, just number of hats. Okay, so let's get x's alone. So let's subtract 550x from both sides. And so this goes away. We have 1,400 here. And then 550 to 1,250 is 7. So it's just 7. We can just divide by 7. And that is, right, this cancels, makes it 200. So 200 hats is break-even point. Okay, so hopefully you would actually want to sell more than 200 hats, right? That's in your business, you would sell 200 hats to just get your money back, but you want to make a profit. So you want to sell more than 200 hats. That gives you an idea of how much you need to sell to make your money back at least. Okay, so here's another one for you to try on your own. Read it, set up an equation, and then solve it. See if you can figure out what the break-even point is here. Press pause. Okay, hopefully you set up your equation to have the expenses, which are costs $864, plus binding and packaging for each book. So this is just your one-time cost or expense, and then this is your expense per book. And then you want to find out the point where the expenses equal the income. And so if you're incoming, you're getting $2 for each book. You'll need 720 books sold just to break even. Okay, hopefully you got that. Moving on. Okay, a dairy owner produces low-fat milk containing 1% fat and whole milk containing 3.5% fat. How many gallons of each type should be combined to make 100 gallons of milk that is 2% fat? Okay, so this one's a little bit tricky, but let's think it through. Okay, you have 100 gallons of milk, and we have two types of milk, right? We have 1% milk and 3.5% milk. So let's call X our gallons of 1% milk, and let's call Y our gallons of 3.5% milk. Okay, and together we want 100 gallons of milk. So we have to have X plus Y equaling 100. Okay? Okay, and then, so this is our total gallons, right? And then the other thing we need is the fat. So let's talk about the percent, or let's call it gallons of fat. Right, so the gallons of fat in the gallons of 1%, right, it's 1% of X. So 0.01X. That's going to be my gallons of fat in my 1% milk, right? And then the gallons of fat in my Y, right, is going to be 0.035. So 3.5% Y. So this is going to be my gallons of fat in the 1% milk. This is my gallons of fat in my 3.5% milk. And what we want is the total 100 to be 2% milk. So that's 2% of 100. And so that's how many gallons of fat we want. Okay, so we have two equations, two unknowns. And what we want to look at is how do we want to solve this? So graphing, we don't need a visual, so we won't graph. We don't have one of these solved for a variable, but actually that's probably the easiest thing to do here. I think solving for Y and substituting in is going to be easier, even though it's not solved, because what we'd have to do to elimination is to multiply something by 0.01 or or negative 0.01, which is a little bit less fun. We could also multiply this whole thing by 100 to move the decimals, or 1,000. That gets messy too. So let's actually just use substitution. So to use substitution, I'm just going to subtract X from both sides here. And then we get Y equals 100 minus X. And then I can just substitute that in for my Y here. And just replace that and then solve that. So let's rewrite it in blue. Blue pen, not blue. There you go, 0.01x plus 0.035. And now instead of Y, I'm going to substitute in this 100 minus X in parentheses. And that's going to equal this side, which is 0.02 times 100 is just 2, right? 2 gallons of milk would be in 2% of 100. So then we can just solve this equation to figure out what our X is going to be. So let's distribute this 0.035. So this is 0.01x plus 3.5 minus 0.035x equals 2. Okay, and then we can combine our like terms here. These two are like terms. So 0.01 minus 3.5 is negative 3.49. Oh, no, sorry. I did that wrong. 0.01 minus 0.035. That didn't sound right. That is negative 0.025 plus 3.5 equals 2. Where's my X? Oh, this is X. And that's it. Okay, and then let's just subtract 3.5 from both sides here. So we get negative 0.025 equals 2 minus 3.5 is negative 1.5. And I keep forgetting this X. Wow, look at me. It's like I haven't done algebra in a long time. This has the X, right? Okay. So then we can divide by negative 0.025. And X equals negative 1.5 divided by negative 0.025. And we get X equals 60. So remember up here, a gallon, this is X is gallons of 1%. So we need 60 gallons of 1% milk. And then here we have this already solved for X. You can just plug that 60 in. Remember, that has to add up to 100. So 100 minus 60 is 40. So we're going to put 40 gallons of 3.5% milk. And that answers our question, right? How many gallons of each type should be combined to make 100 gallons of milk that is 2% fat? And that's what we need 60 gallons of 1% milk and 40 gallons of 3.5% milk. Okay, a little bit tricky. Remember, this example is also in your book. So if you go to 6.4 and look at problem 2, you can see it solved in your book as well. So you might want to take a look at that too. Okay, so try this one on your own. Really try this one. This is kind of, it's actually more useful than a lot of the other word problems we do. So press pause, try this one on your own, and then check back for the solution. All right, hopefully you got 11.25 liters of the 20% alcohol antifreeze, and then 3.75 liters of the 12% alcohol antifreeze. By setting up your equations like this, x plus y equals 15, and then 20%, which is 0.2, of x plus 0.12, which is 12% of y, equals 0.18 of 15, which was 2.7. Okay, and then here is your practice problems. Oops, not many. Enjoy.